AIT, the Austrian Institute of Technology. It is Austria's largest research and development organization. It plays a leading role worldwide, focusing on several infrastructure topics. The motivation behind joining INTERSTORES Consortium, basically within INTERSTORES, we are aiming to two innovations, let's say, with two demo sites. And that's why AIT is there in order to put efforts and to push those innovations to be realized in the future. Basically, I work at the Sustainable Thermal Energy Systems Competence Unit within the research field Large Energy Supply Infrastructure. Within this research field, we are interested in district heating, district cooling topics. At the same time, also, we are playing a leading role in the planning and layout and optimization of large-scale heat pumps and seasonal thermal energy storage as well. And that's why AIT is part of INTERSTORES Consortium to contribute to those pillars as well. Basically, given the experience of AIT with large-scale seasonal thermal energy storage over several years, AIT is leading the work package 3, which is focusing on storage. And normally, I say that this work package is the cornerstone of INTERSTORES as a project. And within INTERSTORES project, AIT is contributing to the development of numerical simulations, starting from component detail simulation models up to the system simulation models. And then at the end, we are going to export those models as digital tools to be implemented later in control strategies as well. Simultaneously, we are contributing also to the optimization of materials as we are focusing on insulation materials by characterizing those materials, focusing on heat transfer and mass transfer. We aim to provide the right and the proper insulation material for our demo sites. Next to that one as well, we are contributing as well to the planning and layout of the charging and discharging heat exchangers and devices for the demo sites in order to realize a fast charging and discharging. By that, we can have an efficient seasonal thermal energy storage and effective one as well. We are also playing a role within Work Package 6 as we are contributing to the techno-economic analysis and the SWOT analysis of the seasonal thermal energy storage to identify where we have the threats, the opportunities for the extension and also the expansion of seasonal thermal energy storage potential. There's one of my favorite questions that I have dealt with throughout my PhD. Basically, when we are discussing seasonal thermal energy storage as an application, we are normally dealing with a huge amount of thermal energy that is being stored over extended periods. So typically, I would say season or couple of months. And that means we need large volumes to host this huge thermal energy. So the subsurface in this case would be the optimal solution to host these large volumes. However, since we are dealing with subsurface, that means we would need definitely specialized construction methods or techniques. Specialized as a term or as a word indicates that we are going to have high investment cost, high capital expenditure, and that means we won't have an effective seasonal thermal energy storage from an economic perspective. There's one of the challenges that we have within the planning and construction. Another challenge that is also related to the subsurface, sometimes you might be unlucky and have some shallow groundwater tables surrounding your seasonal thermal energy storage. And the heat losses from the storage itself will increase the groundwater temperature such that you violate the frameworks or regulation frameworks that you have from authorities, leading to decommissioning of the project or canceling the entire project. In order to mitigate that impact, you need either mitigation measures like cut-off walls or insulation materials. Implementing those mitigation measures basically will lead also to increase the capex beyond the limit that we have. So we will end up again with high capital expenditure and ineffective seasonal thermal energy storage from economic perspective. That's why numerical modeling and simulation found its place favorably in the field of planning and construction of seasonal thermal energy storage that will help researchers, engineers, and also scientists in order to figure out the optimal solution for the seasonal thermal energy storage to end up with the optimal planning layout. So within INTERSTORES, we are exploring an innovative and relatively unexplored approach, which is repurposing of legacy infrastructure. So basically, if you look here around the European Union, you will find a lot of abandoned mines, abandoned basins, abandoned caverns, or tunnels as well. How can we use those infrastructure, those legacy infrastructure, repurpose them, rehabilitate them, and then we use them as seasonal thermal energy storage applications such that we can reduce the construction cost. So that was the main innovation that motivated me to join this consortium as AIT as well. And the second innovation, we are aiming to achieve a volume of 1 million cubic meter seasonal thermal energy storage in Finland with a second demo site that we have with INTERSTORES. Now, if you talk to me a couple of years back, I would tell you this is just a dream that will never happen. But within INTERSTORES, when I hear that one, I said, okay, I'm in and we are going to make it. So